Hi everyone, welcome to this trigonometry maths class, and we are going to be looking at the basics of trigonometry in this class. So I'm going to make trigonometry really easy for you, so make sure you watch the entire class. And before we look at trigonometry, I just want to mention that we have this website manochaacademy.com. So guys, do check out our courses. The links are given below, and we've got big discounts going on right now. So you can take these courses on our website. They have more detailed lectures. We have interactive videos, quizzes and questions, and you also get to attend special live classes. And soon we'll be launching the Chemistry Class 9 CBSE course. So guys, do check it out, and if you haven't subscribed to our YouTube channel already, hit the subscribe button right now and click on the notification bell so that you don't miss out on any new videos and live classes. Okay, so guys, do share it out with your friends so that we have more people joining in for these classes. Alright guys, are you excited about the trigonometry topic? So we are going to dive right into it. And good evening, hello, so great to see all of you here, right? Hi Satyanarayanan, hi Devasri, hi Sushanta Das, hi Arjun Malhotra. Good evening everyone. Sorry if I can't take everyone's name here. We are going to be doing the maths topic of trigonometry today, and I'm going to make the concepts really easy for you. So you might, so suppose you're standing in front of a tall building like the one you see here, right? Do you know which building is this? It's the tallest building in the world, Burj Khalifa. Okay, and guys, if you want to measure its height, how do you measure it? So one option is to go right on top of the building and drop a long tape, right? And measure the height of the building. But you can actually apply the concepts of trigonometry. Very good. You guys recognize the building, Burj Khalifa, that's right, in Dubai, right? And so you can actually apply trigonometry to find the height of the building without going to the top. Okay? And suppose you're standing on a bridge like this, right? How do you find the width of the river? Of course, one option is to tell your friend to hold a really long tape, right? So let's say we want to find the width of this river here. So this width, right? So you can tell your friend to hold a tape and you stand on the other end. So it's going to be really difficult, but you can apply the concepts of trigonometry and do it really easily. Okay, so you can watch my video on this. So I have this video on the applications of trigonometry, or what is known as heights and distances, where I talk about this whole topic in a very interesting way. So I'm sure you'll enjoy the video. So do check it out. But in this class, we are going to be focused on the trigonometry basics. So before we go to applications of trigonometry, let's really understand the basics so that you guys find it really easy. All right, guys. So are you excited? Let's go ahead and start the topic. So before we look at trigonometry, remember Pythagoras theorem, right? So what does Pythagoras theorem say? So you guys know that if this is a right angle triangle, right angle means this is 90 degree, right? So this is a right angle triangle, and let's say the triangle is marked as ABC. Okay, so what do we know from Pythagoras theorem, guys? So we know that the square, so we can write this expression, right? The hypotenuse square, so AC square, is equal to AB square plus BC square. So the hypotenuse, which is, you can see, this is the hypotenuse. So let me label that as H here. So let's put H for hypotenuse. This is the perpendicular, which we'll talk about, and this is the base, right? So let's understand what these sides mean. I think you guys know it already, but remember that hypotenuse is the longest side and it's opposite to the 90 degree angle, right? Opposite to the right angle. And the base, okay, so the base is this one we've defined here, right? So, and perpendicular is this this side, right, which we're going to talk about. Okay, so in this thing we can say the hypotenuse square, right? So the hypotenuse square is going to be equal to the P square plus B square. Okay, right? So that's one way of thinking it. But in Pythagoras, we just talk about the sides. So you guys can focus on this relation, AC square equals AB square plus BC square, right? For example, if we take some values here, so let me erase this notation, we'll come to that, right? So if you, what are we saying? The square of the hypotenuse is equal to sum of the square of the sides. So if I take some values here for you, so let's say this is 3, this is 4, then this side is going to be, so AC square is going to be equal to square root of 3 square plus 4 square, right? So AC is going to be square root of this, and if you work it out, it's going to turn out to be 5, right guys? So you know this basic of Pythagoras theorem. So if you're given two sides, like we were given these two sides, right? 3 and 4, in a right angle triangle, we can easily find the other side. Clear? So guys, the important thing here is we are looking at the triangle must be right angled, right? So we are looking at a right angle triangle. Can you see the 90 degree? Okay, so Pythagoras works for that, where AC square is AB square plus BC square. Clear? The hypotenuse square is the equal to the sum of squares of the other two sides. So this, I think all of you guys are familiar with Pythagoras theorem. Now let's look at what is trigonometry. Okay, so this similar thing is, again we are dealing with a right angle triangle, means this angle is 90 degree, and let's mark our triangle here. So this triangle is ABC. Okay, and now in trigonometry we're going to mark this angle here. So let's mark the angle here with theta. So I'm using this orange color, and usually you can we can call it angle C, like we call it in geometry, right? But in trigonometry, this is the common symbol theta, or you can say it's angle X or something, right? So the symbol that's used is usually theta here. Okay, and now let's take a look at what we can call these. What do we have here, right? So what do we have is that we have a right angle triangle, and we know this angle theta, right? Okay, and now with the help of this, and let's say we are given some side. So let's say we know that this side is 3 and this side is 4. So if we are given two sides, we can actually find the angle theta using trigonometry. Okay, so in Pythagoras theorem, we were interested only in the sides, right? Sides of the triangle. Now we are looking also, you know, the triangle has angles also. So we can find this angle theta, or we can find this other angle if we are given two sides, right? Or I can put it this way. Let's say we are given one side. So in a right angle triangle, if we are given one side, let's say 3, and one angle theta, so let's say that angle is 60 degree or something. So if you're given these two values, then you can find all the other things. So you can find the angles and the sides, right? So guys, be clear here that again we are dealing with the right angle triangle, and now we are also looking at this angle that we are interested in, theta. So given theta and this side 3, we can use trigonometry to find the value of this side, or the other angle over here. So everything we can find, right? And we are going to talk about that. So let's talk about this important point called trigonometric ratios. Okay, so we are looking at this right angle triangle here. Okay, and remember this is our angle theta. So now please follow me carefully, because we're going to talk about those hypotenuse, perpendicular and base, the important terms, right? So as we know that the longest side, which is opposite to the 90 degree, is the hypotenuse. So let me label it with H. Okay guys, right? And what is this side called? So the side that contains the 90 degree and the angle theta. Okay, so guys, do you know what is BC known as? So remember this side, the side which has the right angle and the angle theta, what is it called? So what should I label this one as? Okay, very good. Base, right? So this is the base, right? So B for base. So hypotenuse is the side opposite to the 90 degree, and base is the side which contains the 90 degree and the angle theta. Can you see both the angles are lying on it? And guys, what is the side which is opposite to the angle theta known as? So guys, do you know what should I label AB as? Okay, very good. I can see a lot of answers here. Excellent. I want all of you to participate. Very good. So this is known as the perpendicular. Okay guys. So AB is called the perpendicular. Good. Okay. Actually, let me change the color scheme because you'll remember perpendicular with the P. So P for pink here, right? And base is blue. So let's put hypotenuse with a green color here. Okay. So it's easy to remember, right? So pink perpendicular we have here, the base and the hypotenuse, right? And now we can take the ratio of the sides, which are defined as the trigonometric ratios. So if we take the ratio of the perpendicular by the hypotenuse, so P by H, right? So let's say I'm taking the ratio AB, which is the perpendicular here, by AC, and that's basically, you can see, that's going to be perpendicular by the hypotenuse. So that is, this trigonometric ratio is known as sine theta. Okay guys, so do you guys know sine theta is it's the ratio of perpendicular by hypotenuse. This is how it's defined. So let's write that down here. So sine theta is basically AB by AC, which according to our notation is perpendicular by hypotenuse. Okay. Similarly, we can define the ratio of base by hypotenuse. So this BC by AC is defined as cos theta. So we say cos theta is called base by hypotenuse. So these are the standard definitions, right? We can't change it. So these are the notations. So sine of theta means sine of this angle is B by H and cos theta is B by H. Clear? And then if you take the other ratio, so we are taking ratio of two sides, right? Not the angles, the ratio of the two sides. Now if you take the ratio of AB by BC, so which is P by B, we are going to get, so what do we get guys? So it's going to be tan theta, perpendicular by base. Alright guys, so clear? So what is the key thing in trigonometric ratios? Note with this very simple diagram I've shown you, you need a right angle triangle here, and then we mark this angle, it's called theta. Usually we don't call it X or A, right? Or C here, it's theta. And so sine theta is P by H, cos theta is B by H, base by hypotenuse, and tan theta is P by B. Okay, I see some of you are using the terms opposite and adjacent. Fine, if you're using that in school, you can relate to that. I find the P, B and H easiest, but sure, you can use those terms as well, right? Opposite, adjacent and hypotenuse. Fine. So let's take a look here. Now what is cosec theta? So cosec theta is defined as the reciprocal of sine theta. So that's going to be 1 by sine theta. So the reciprocal of this guy. So what is the reciprocal going to be? That's pretty simple, right? It's going to be H by P. So hypotenuse by perpendicular. Okay, simple. Now what is sec theta? Sec theta is defined as 1 by cos theta. Okay, so these are the definitions again, and it's the reciprocal of cos theta. So simple, it's going to be, if you see, hypotenuse by base. We are just going to invert this guy here, right? We are just inverting this. So pretty simple. And similarly, cot theta is defined as 1 by tan theta. So these are just the reciprocal ratios. And so what is that going to be, guys? It's going to be base by perpendicular. Okay. So pretty simple. Actually, you guys just need to learn what is sine theta, cos theta, tan theta, and these guys are just the reciprocal ratios. Excellent. Okay. So guys, is this clear? It's pretty simple, and we are only dealing with a right angle triangle. Okay guys, don't forget that. And as I defined you, the hypotenuse is opposite to the 90 degree. The base is the side which contains both 90 and theta, and perpendicular you can see is opposite to the theta. Very good. So now I have this question for you guys. So what is cos theta for the triangle below? And this is again a right angle triangle which is right angled at B. So guys, which option do you think it is? I have 4 options here, A, B, C and D for you. So guys, what do you think is the right answer here? So what is cos theta, where the angle theta is here? So this is our angle theta, right? Can you see that? Okay, so this is the angle theta here. What is cos theta for the triangle below? So which option? Okay, so I'm seeing some people are saying A, some people are saying C. Okay, guys, what do you think? So very good. I see a lot of participation here. It's great to see that, guys. And guys, do hit the like button if you haven't already. And do remember to share out our videos with your friends so that we have more people joining in. So C, D, okay, I see a lot of answers here, guys. So let's see, what does this question say? So it's asking for what is cos theta? We're interested in this guy, right? So what is our cos theta definition? So cos theta we know, so from our previous diagram, we saw it was base by hypotenuse, right? So let's write that down here. So cos theta is basically base by hypotenuse, right? So we need to decide who's the base and who's the hypotenuse here. Okay, so take a careful look here. Now the interesting thing you can see is the difference between this and this diagram. The theta was down there, but now the theta is up here. Okay, so we need to be a little careful. So what is the hypotenuse here? So the hypotenuse is clearly opposite to the 90 degree. Okay, right? So guys, you can see that AC is the hypotenuse, and let me write that here. Clear? This is our hypotenuse AC. Now guys, which one is the base? Is this the base, BC? What do you think is the base here? Okay, so be very careful. Don't think that the horizontal line is the base here, right? As if this is a building and this is the base of the building. No, base, remember the definition is the side that contains theta and 90, guys. Okay, very good. I see a lot of you are writing that AB is the base here. So be very careful. This is our base because it contains 90 and theta. And what is the perpendicular? The side which is opposite to theta. So this is our perpendicular. So what should our answer be here, guys? So base by hypotenuse is going to be basically, base is AB. So it's going to be AB by the hypotenuse, which is here is AC, right? So the correct answer here, very good guys, is option C. It's not option A. That's not right because it's not BC by AC. Here the base is AB. Clear? So very good. So just be careful what angle you're considering and which is the perpendicular base and hypotenuse. Okay. So I hope you got the concept there with those two diagrams. Very good. Now let's take a look at what is the relation between sine theta, cos theta and tan theta. So again guys, we are dealing with the right angle triangle here. So this is our right angle triangle ABC, and let's mark in the theta. We'll take this one for convenience, right? I won't confuse you with the theta on top there. Okay. And we saw that these sine theta, cos theta were defined like this, right? We talked about that. So what is we are interested now in the relation between sine theta, cos theta and tan theta. So let's write these guys here. So before we write, let's quickly mark this is the perpendicular, this is the base, and this is our hypotenuse, right guys? And sine theta is defined as perpendicular by hypotenuse. Okay, and what is cos theta? Simple. Cos theta is base by hypotenuse. So learn these up so that you don't confuse them. And tan theta is, okay, tan theta is basically, what is it guys? Perpendicular by base, right? So simple. These are the trigonometric ratio of the sides. And very good. I see already. So Srijan Ganguly is writing, right? Tan equals sine by cos, right? Even K. Gautam says that, right? Manu Nath says that. Excellent, guys. So that's absolutely the right answer, that the relation is tan theta is equal to sine theta by cos theta. That's a very important relation here, and that's very easy to prove because if you take sine theta, right? So if you take the numerator, that's basically going to be perpendicular by hypotenuse. Perpendicular by hypotenuse, and the denominator is cos theta, so that's going to be base by hypotenuse, right guys? And you can see that the hypotenuse will cancel, and so we'll get, so if you're looking at the right hand side, and we get perpendicular by base here. Can you guys see that? And perpendicular by base, you know, is basically that's equal to tan theta, right? So if we start with the right hand side, this is what we get, and you can see that RHS is equal to tan theta. So very simple, okay? So tan theta is sine theta by cos theta because the hypotenuse will cancel. And similarly, you'll also have the relation that cot theta, right? So what is cot theta defined as? So take a look, cot theta is 1 by tan theta, right? So the reciprocal of tan theta. So similarly, cot theta, guys, is going to be equal to cos theta by sine theta. So these are very important relations that will help you in the questions. So do remember them. Pretty simple to derive. So if you ever get confused, you can try it out. But these things, once you revise your chapter, you need to learn these so that you can use them quickly in your questions. Okay, guys? So is that pretty simple? All right. Now I have a question for you. If sine A is 5 by 13, this is of course in a right angle triangle. I didn't write all the details there. You need to find tan A. Okay. So how do you do this question? So first, to visualize, let's draw the triangle. So we are talking about a right angle triangle here, right? And it's right angle here. So this is 90 degree, okay? And let's say this is A, right? B, C, right? And we've been given sine A is 5 by 13. We need to find tan A, okay, in this triangle. So this is, as you can see, in trigonometry, you need a right angle triangle. So this is the question, guys. Go ahead and try it out. You need to find tan of A. So how are you guys going to do it? Great, I'm already seeing some answers. Very good, guys. So how do we do this question? Let's take a look. So we've been given sine A. Sine A is 5 by 13, right? And remember, sine means it's going to be perpendicular. So this is basically perpendicular by hypotenuse, remember? Okay, so we've been given the ratio 5 by 13, right? So guys, come on, I want all of you to try here. So how are you going to do this question? Okay, so one way, we've been given this ratio, so we can take this as, let's say so let's mark out the things here. So this is our perpendicular, and we are interested in this angle A, right? So this is our theta, or the angle A here, right? So this is our angle A. This is the base then, and this is our, sorry, the base needs to be in blue color. I was using blue, right? So this is the base, and this is the hypotenuse, right? And we've been given that sine A is 5 by 30. So let's take the values like this. So we know the ratio, so we can take P as 5. So this can be basically 5K can be P, and the hypotenuse we can take as, so P is 5K, right? And the hypotenuse we can take as 13K, right? Because they are in that ratio, so K will cancel, where K is some constant, right? Because we don't know what is it. So we can take P as 5K and hypotenuse can be 13K. You can even take 5 and 13, but to be more accurate, you know, it's a ratio. So we don't know what is P. We don't know is it exactly 5. So we are taking 5 times a constant, and H is 13K. So now if you look at this right angle triangle, you just have to apply Pythagoras theorem, right? So the base, you know, the base square is basically square root of H square minus P square, right? And if you work that out, you're going to get the base as 12K. So go ahead and do the calculations, right? And now we need to find tan A. So guys, what will tan A be? Tan A is basically perpendicular by base, right? And so let's see what that works out to be. So tan A works out to be perpendicular, given here is 5K. So we're going to take that and divided by the base, which we calculated using Pythagoras theorem, as 12K. So K cancels there, and what do we get, guys? Excellent. I see a lot of you got the right answer. It's working out to be 5 by 12. Superb. Okay. So is this clear? Right. So that is absolutely the right answer. I see a lot of you have got it correct. 5 by 12. So this is how you solve it. You just take the sides 5k and 13k, and then you compute the other side using Pythagoras theorem, and it's pretty simple, right? Then you apply the ratio. Very good, guys. Excellent. Now let's take a look at our next question. If tan A is root 3, you need to find cos A. So how do you guys do this? Okay, so again, guys, you need to take the same thing. We'll take a triangle, right? A right angle triangle here. Don't forget the right angle. Okay, so this is our right angle triangle, and let's say we are interested in this angle A here. So this is the angle A, right? And so that's all. This is our A, and we've been given tan A is root 3. Tan of A is square root of 3, and we need to find cos of A. So guys, can you try it? Okay, so what do you think is the answer going to be here? So I want all of you to try. So again, the same thing, guys. How do we do this? Tan, tan of A is defined as, so this trigonometrical ratio is perpendicular by the base, right? Okay, so we can say that this is root 3 by 1, right? So we can take our perpendicular is root 3 and the base is 1. So let's mark out our perpendicular here. This is the base and this is our hypotenuse, simple, right? And so perpendicular, we'll take it as root 3, or you can take root 3k. So this is root 3 and the base is 1, right? And now we need to find the hypotenuse. We don't know the hypotenuse. Okay, so clear, guys? So we've put these values in. So how did I say that? It's because the ratio of perpendicular by base is root 3 is to 1, or you can take, to be more correct, root 3k and k. So whichever way you want to do it. Okay, and then you need to find the hypotenuse. And how do you find the hypotenuse? Simple. Hypotenuse is going to be perpendicular square plus base square by Pythagoras theorem. So guys, if you go ahead and solve that, how much do you get? So what will the hypotenuse be? I think it works out to be 2, right? Root 3 whole square, right? So that's 3 plus 1 and square root of that. So let me show that to you if you're confused. So this is going to be root 3 whole square plus 1 square, right? I'm not using the k here. So that's going to be square root of 4. So our hypotenuse works out to be 2 here. So let's go ahead and substitute that, right? So if this is our perpendicular, and so we need to find cos of A. So guys, what is cos of A going to be? It's defined as base by hypotenuse, right? So cos A is base by hypotenuse. So that is going to be, base is 1 here. So pretty simple. So go ahead and substitute here. So base is 1, we took it as, and hypotenuse is 2. So the correct answer, very good, guys. A lot of you got D. D is the right answer, and we worked it out in this simple way. Okay, so can you see we are dealing with these trigonometry ratios, and here we are basically applying Pythagoras theorem. So very simple trick, just draw the diagram, look at the ratio what you're given, and I showed you the k technique, right? So this can be taken as root 3k, k, and then this will basically work out to be 2k, or you can do it without the k, whichever method your school follows, right? And then you'll get the correct, both the times you'll get the correct answer because k gets cancelled. Okay, guys, so pretty simple, right? Now let's talk about this. You might have seen this in your books. There's a trigonometry table, okay? Because there are standard values for when theta, so in a right angle triangle, so we are talking about this right angle triangle, right? Which is right angle here. So in this triangle where we mentioned this theta, right? Theta is this angle. We can actually, we have these standard values of sine theta, cos theta and tan theta for these values. These are for when theta is 0, when theta is 30, 45, 60 and 90. Okay, and guys, you need to remember this table. So can you help me fill up this table for those of you who know the values, and those of you don't worry, you just need to learn up this table so that you're not making any mistakes in the test. Okay, guys. So go ahead and so let's start with our sine row here, right? And I'll teach you an easy way to remember this table. So what will sine 0 be, guys? So sine 0, very good. It's defined as 0. Okay. So sine 0 is 0. That means when angle theta is 0, sine of theta, so sine of 0 is 0. Now what is sine of 30? Okay guys, so what is sine of 30? So sine 30 is basically going to be half, right? 1 by 2, very good, half. 0.50, better way to remember it is half. Now what is sine of 45 degrees? Okay, so what is sine of 45? That's 1 by root 2. Okay, and what is sine of 60? Very good. So a lot of you know the values already. This is root 3 by 2. And these values are also very useful for physics questions, right? So we use them in maths and physics, right? And what is sine of 90? It's defined as, it's 1. Okay, so we need to learn these values. Now let's fill in the cos values. So cos value is very easy because it's basically the opposite of the sine table. Okay, so sine 0 was 0, right? But in this case, so you just need to reverse it, right? So cos 0 is going to be 1 because sine 90 was 1. So cos 0 is going to be 1. Very good. So just invert the table. And what is cos 30 going to be? It's going to be the value of sine 60. So that's going to be root 3 by 2. So guys, can you see I'm just inverting the table? And you can't invert the center fellow, right? So this is going to be the same. Cos of 45 is 1 by root 2. Okay. Now what is cos of 60 going to be? The value of sine 30. So it's as if you're taking a mirror image, right, of the thing. So we are just flipping that first row. So this cos 60 is going to be this value, sine of 30, right? So this is going to be half. And what is cos of 90 going to be? The value of sine 0, right? The first value in the sine table. So cos 90 is defined as 0. Clear? Okay. And now tan theta, you can either divide sine theta by cos theta. Remember, tan theta is sine theta by cos theta, but better to learn the values so that you don't have to think during your test. So tan theta is going to be 0 because it's you just need to divide these two rows. So 0 by 1, very good. And what is tan of 30, guys? Do you know? Okay. So again, if you do the division, you're going to get 1 by root 3. So if you divide these two values, and tan of 45 is 1 because they are equal, and tan of 60 is root 3. So it's the reciprocal of 30. Okay. And tan of 90, guys, do you know what is tan of 90? So, or if you don't know, can you compute it from this table? Because as I mentioned, tan theta, remember, is, so we discussed this relation, tan theta is sine theta by cos theta. So who can tell me what is tan of 90? Come on, guys. So even if you don't know, you can calculate it from this table. So very good. Excellent. I see a lot of you have written the correct answer. You guys are saying not defined, right? Because if you do tan of 90, it's going to be basically 1 by 0. And you know that anything divided by 0 is undefined. Okay. Very good. I see Hariharan has written infinite. In some books it's written. So this is also taken as you have the concept of infinite, right? Or you can write it with the infinity symbol here. So both are allowed. Usually in maths books, you'll see it as not defined. Sometimes in physics questions, we take it as infinity, right? So because 1 by 0 is not defined or taken to be a very large value as infinite. Okay. So actually the correct math probably value is 1 by 0 as not defined. Okay. So guys, don't forget to learn up this table. And what's the nice trick I taught you? Just learn the sine theta row. Okay. And you just have to invert it for cos theta. Okay. So it's going to be, so this is 0, half, 1 by root 2, root 3 by 2 and 1. And it's the inverse in the cos. And the tan is actually the division of the two, but just learn it up. Okay. So that you don't have to remember it during your test. Clear? And guys, this is really easy to prove. Okay. So I'd really encourage you to try to prove these. For example, if you take, let's try this value. So if you take angle theta is 45 degree, right? So let's say this angle here is 45 degree, right? Then you know that this angle is also going to be 45, right? So can you see that we have an isosceles triangle here, right? These two sides are equal. Okay. So I'm going to take the two sides as, so let's take them as A and A, right? So now we can apply Pythagoras theorem. So what is AC going to work out to be? So AC square is basically AB square, which is A square, plus BC square, which is again A square. So AC square is 2A square. Oops, I wrote B square by mistake, right? So it's A square plus A square, so that's going to be 2A square. So what is AC? It's root 2A, right? Or A root 2, right? Is that correct? So can you see that, guys? So now if you, so we have taken when angle theta is 45. So that means we are focused on this row in the table, right? The 45 one. So now let's take a look. If you take what is sine of 45. So if you follow me, we are trying to check this value. Sine of 45 is going to be perpendicular, right? So let's mark them. This is our perpendicular. This is our base here. And this is our hypotenuse. So sine of 45 is going to be perpendicular by hypotenuse. So that's going to be A by A root 2, right? So that's 1 by root 2. Pretty simple. Okay. Now what is cos of this thing? That's going to be base by hypotenuse. Again, A by A root 2, right? So that's going to be 1 by root 2. Okay. And tan of 45 is going to be perpendicular by base and both are A. So pretty simple, 1, right? So guys, I would encourage you to take a look at the proofs for 60 and 30 also, right? Because you can use an equilateral triangle for that. So go and check your textbooks and you can prove these values in a very simple way. Okay guys, and make sure you learn this table because it's a very useful table for these standard values 0, 30, 45, you can't see the 60, 60 here, right? And 90. All right, very good. So now let's take a look at this question again. So remember we had solved this question here, tan A equal to root 3, right? So let's try this again. So if tan A equal to root 3, find cos A. So can we do this quickly using the table here? So I want all of you to try this question. Come on guys, how do you find this? So if tan A is given as root 3, you need to find the value of cos A. So go ahead and all of you try this question guys, come on. So I want all of you to try this. So if tan A is root 3, find cos A. And this I'm going to show you the shortcut technique. Last time we had used Pythagoras theorem and all. So I would encourage you to use this table here. So I'm going to bring up the table here. So try it with this table. Okay. So can you find the option for me? Right. So what is the question? If tan A equals root 3, you need to find cos A. That's our question. And go ahead and use the table. Okay, very good. I'm seeing a lot of answers here. So what is the trick? The trick is we can see that this looks like a standard value. Tan A is root 3. So if you look at our tan table, can we find it here? Let's take a look. Ah, there it is, right? So can you see this value here? Oh, that's too big, right? So can you see this value? Tan of 60 degree is root 3. Okay. So therefore, if you go back to the question, because it's given to us that the question says tan A is root 3, and from the table we know that A is 60. Why? Because we know that tan of 60 is root 3, right guys? As you saw from the table here, can you see? Tan of 60 is root 3. Therefore, we can conclude that A is 60 degrees. It's a standard value, right? A simple value here. So A we know is 60. Now finding cos A is really easy because cos A means we need to find cos of 60 degree. And again, we can use our standard table. So if you take a look, what is the value of cos 60? So you just need to look at 60 degree and the cos row here. It's going to be half. So, right. So that's as easy as that. So if you see these standard values, and very good, I see a lot of you got the right answer. You guys rock. I mean, you guys are really fast. Even before I gave you the question, many of you had started writing half. So excellent guys. And that is absolutely the right answer, D. Okay. So please take a note here. What I showed you two techniques. So we did this same question in the lengthy way here, right? Before we went to the standard values, because I want you to have the basics of trigonometry absolutely crystal clear. Okay. So if you see here what we did, tan A is root 3. We found cos A using this Pythagoras theorem. Okay, so we applied all this Pythagoras theorem, calculated the sides, and we got the answer as half. But now, since we know this fancy table, we can actually apply it here, because we recognize that, oh, tan A is root 3, that means A is the standard value, 60. Okay, and we applied it and we quickly found out what is cos A. Right, guys? Okay, so is that pretty simple? Right? And there are some square relations also. So trigonometry has some square relations. So you have sine square theta plus cos square theta is 1, right? So what does this mean? So I'll just give you a brief introduction, and maybe we can talk about these in more detail in the next class. For you to know, if you see this in your book, what is sine square theta? So be very clear about this notation. So this funny notation, sine square theta actually means sine theta whole square. Okay, so it's nothing but sine theta times sine theta. Okay, so don't be confused by that sine squared theta. It's basically sine theta times sine theta. Clear? Okay, it's just a multiplication. Similarly, cos square theta is cos theta whole square. Clear, guys? Right? And then there's this very interesting relation, as you can see in the first relation here, that sine square theta plus cos square theta is equal to 1 for any angle theta in the right angle triangle, right? So when theta is between 0 and 90, this relation of sine square theta plus cos square theta, right, is equal to 1, right? And can we prove that, guys? Is it easy to prove? Let's take a quick look at how to prove this relation. So if we say sine square theta, so sine square theta is what? Basically sine theta whole square, right? As we said here, sine theta whole square. And what is that going to be? It's basically perpendicular by hypotenuse whole square, right? So we can say that's p square by h square. Does that make sense, right? Because sine theta is perpendicular by hypotenuse. And similarly, guys, cos square theta is going to be, so that's basically cos theta whole square, which is basically base by hypotenuse, right? So base by hypotenuse whole square, right? Makes sense? And so that's going to be b square by h square. Okay, and this we are doing again in our right angle triangle. So don't forget our right angle triangle here, right? So this is 90 and this is our theta that we are talking about, and here we have our perpendicular, base and hypotenuse. Okay, simple. So we are talking about our right angle triangle here. And now if you add these two, let's see what do we get. So if we do sine square theta plus cos square theta, what are we going to get? We are going to get p square by h square plus b square by h square, right? Can you see that? And so you can see the denominator is same, so it's going to turn out to be p square plus b square by h square, right, guys? And guys, in the right angle triangle, what is p square plus b square, right? Pretty simple. You know that it's Pythagoras theorem. So it's going to be hypotenuse square by Pythagoras theorem, because h square we know is p square plus b square. And so these guys are going to cancel and you're going to get 1. Okay, so very simple proof, guys. Just see it. It's really easy to prove that. And similarly, the other statements are also easy to prove. So for example, if you take a look at the next statement, 1 plus tan square theta is equal to sec square theta, right? So how do you prove that, guys? So what do we need to do here? So it's pretty simple. I'll teach you a very simple technique. So for this, guys, just divide this relation. So take the first relation and divide it by cos square theta. So if we divide this guy by cos square theta, right? And this also by cos square theta, and this by cos square theta, you'll see you'll get this, right? Because can you see, guys, here? So carefully follow me, that sine square theta plus by cos square theta is tan square theta. So this term cos square theta by cos square theta is going to cancel, so that's going to be 1, and 1 by cos square theta is sec square theta. Why? Because sec theta is the reciprocal of cos theta. So it's very simple to prove this, right? And similarly, you guys can try the next one also. You just have to divide again, okay, by sine square theta. So pretty simple. I've shown you how to prove it, and maybe we'll talk about more about these square relations in our next class, okay? So guys, do you want to try this question? Find the value of the expression below when theta is 30 degree, right? So sine square theta plus cosec square theta plus cos square theta minus cot square theta. So how do we find this when it's given to us that angle theta is 30 degree? So guys, go ahead and try this question. So how will you solve this, guys? Come on, I want all of you to try this question here, guys. So how will you solve this question? So my hint is, take a look at what's been given. Sine square theta plus cosec square theta plus cos square minus cot square theta. And you need to find what this expression is going to be when theta is 30 degree, right? So basically what they're asking is, you need to calculate sine square 30. Let me write that again. So they are asking to calculate sine square 30 plus cosec square 30 plus cos square 30 minus cot square 30, right guys? So this is what the question asks. And how do we find that out? So one option is, and we know that sine square 30 is nothing but sine 30 whole square, and similarly the others, right? So one option is we can use our table, because again you can see that this is a standard value of 30. So one option is to use this table and go ahead and start substituting the values, okay? And if you do that, I'm sure you'll get the right answer. So if you go ahead and start substituting for each term, you'll end up with the right answer. But let me show you a very simple trick how to solve this without substituting the values, okay? So let's see if we can use the square relations that we learned. Okay guys, so let's take a look at the terms here. Can you see that we have this sine square theta plus cos square theta in there, okay? And we have another cosec square theta minus cot square theta. So let's rewrite our question as, it's basically sine square theta plus cos square theta, right? So I'm just grouping these two terms together. So first I'm grouping the first term and the third term, and then let's group these guys, the cosec square minus the cot square. So plus cosec square theta, right, minus cot square theta. Very good. I see a lot of you are already writing the answer. Excellent guys. Great to see you participating in these questions. So please go ahead and try this out, and it's very simple. So if we use our relation, right, the square relations that we saw here, so sine square theta plus cos square theta is 1, right? So if you take a look at this term, so this entire thing by the relation given here, sine square theta plus cos square theta is 1. So this is nothing but going to be nothing but 1. And let's take a look, group these terms, right? So this is cosec square theta minus cot square theta. And what do we know here? We know that 1 plus cot square theta is equal to cosec square theta. So we know this thing, that let me write that here. We know that 1 plus cot square theta is equal to cosec square theta, right? Can you see that? This was our relation, the last one here. Can you see that guys? 1 plus cot square theta is cosec square theta. Therefore, we can say that cosec square theta minus cot square theta is 1, right? Just bringing it to this side. So this term is going to be 1. So very simple. So look here, just by using the relation, we didn't have to substitute any value. We didn't even have to use the table. If you use the table, you'll get the right answer. Believe me, you can try that also and substitute the values and do the calculation. And if you just add up 1 plus 1, we are going to get the answer is 2. Excellent guys. A lot of you got, I see Uma Shankar, they've got Jamie Alex, right? Very good. Srinivas Murthy, excellent guys. A lot of you have got the correct answer, D. So this is the easy trick where you apply the square relations, right? So in trigonometry, make sure you're learning the formulas, the relations and the table, and try to apply the easiest one. So we've learned that we can solve the questions in different ways here, but and I've showed you the basics of how to solve it, but you need to apply whichever one is the best method. And I've got a practice homework question for you guys. So in a right angle triangle where A is 90 degree and tan C is √3, you need to find for me sine B cos C plus cos B sine C. Okay, so let me add that. In a right angle triangle, I should write ABC, right? So it's the triangle ABC. Okay, so in a right angle triangle ABC, A is given as 90, tan C is √3. Guys, you need to find this thing. And believe me, it's pretty easy. Just apply the concepts that you've learned here. Sin B cos C plus cos B sin C. Okay, and I'm sure you'll get the right answer. And do write your answer in the comments below. Guys, I look forward to reading everybody's comments, and some of you are really fast, so I want all of you to try writing the answers, because it's great to see your comments, and I promise to reply to them as soon as possible. So go ahead and try this question, and I hope you found this class on trigonometry basics useful. So do hit the like button right now. And if you haven't subscribed to our YouTube channel, hit the subscribe button right now. We are having live classes on physics, chemistry and maths at 8 p.m. daily. So guys, hit the notification bell so that you don't miss out on these live classes, and share it out with your friends so that we have more folks joining us, and we can have more people in these live classes. So thanks a lot for your support. It's great to read your comments. And guys, do check out our website, manochaacademy.com. And as I said, I have good news that tomorrow we'll be launching this chemistry CBSE class 9 course also. So do check it out. We've got great discounts going on. Links are given below. And it's awesome to read everyone's comments. So thanks a lot, guys, from the Manocha Academy team. Thanks to everyone for your love and support. And thanks for participating and joining in this live class. You guys were awesome. I see a lot of comments and a lot of good answers and questions. So I'm sorry if I can't answer each and every question, but you know, I was keeping a track of what you guys were saying. If you have any doubts, put it in the comments below, or if you have suggestions on topics, because I saw a lot of you were wanting a class on trigonometry. That's why I took it today. So guys, put in the comments what topics you want. I won't be able to take each and every topic, but I'll try to take the most popular ones. And we are also having live classes on our website starting from next Monday. So guys, do check out these courses. You'll find them really useful for your exam preparation. And all right, so do check it out. Okay guys, hope everyone's doing great. Take care and stay safe. And thanks for joining in this trigonometry live class. Take care guys. Bye.